The very basics of geometry stem from lines and the angles that they create. So these are a list of the different angles that we'll be using and how to classify them. We have an acute angle. That is an angle that is between 0 and 90 degrees. Right angles are exactly 90 degrees, and they're denoted by this little box that shows up on the inside of the angle. Anytime you see the square, you can assume that it is a 90-degree angle. If you do not see the square, you can't necessarily assume that it is 90 degrees. Obtuse angles are between 90 degrees and 80 degrees. Straight angles are exactly 180 degrees. Reflexive angles are greater than 180 degrees. You can see the reflexive angle is denoted by the circle. So if you see the circle on the outside of what appears to be the angle, this is the true angle that they are asking for, this larger angle. Full rotation angle is 360 degrees. Now let's identify each angle as its type of angle it is. So this first one, it's larger than 90 degrees, but it's smaller than 180 degrees, so it is obtuse. This angle looks like it's about the same angle, but they're actually talking about this outer larger angle, so this is a reflexive angle. This one doesn't even look like an angle at all. It's a straight line, so it's a straight angle. The angle right here, it doesn't show, but they are talking about this angle right here. This one is acute. I always was told by my high school math instructor to remember the difference between obtuse and acute. Acute things tend to be small, so acute angle is a small angle. Now, there are properties to angles. We want to try to find the measure of each unknown angle. So let's take a look at this. We have a straight line that is cut by another straight line. Well, we know that this full angle right here, this is a straight line, right? Therefore, this angle A has to be the straight line angle minus 57 degrees. The straight line angle is 180 degrees. So we'll take 180 degrees and subtract 57 degrees, and we'll get, don't trust myself on doing math on video, I get too nervous, 123 degrees. So angle A is 123 degrees. Now let's look at angle B. Angle B is also a straight line that is cut by this side here. So this right here is 180 degrees as well, right? Because that's a straight line. And we just found out that angle A is 123 degrees. So to find angle B, we'll take 180 degrees minus 123 degrees and get 57 degrees. And that is angle B. This is a nice property to know. When you have a line that's cut by another line, the opposite angles are always going to be equal. So that's something you can remember so you don't have to calculate that every time. Angle C is opposite of angle A, so we can use the property that we just learned, and angle C is 123 degrees, just like angle A. Now we talked about parallel and perpendicular lines, but just as a reminder, perpendicular lines form a 90-degree angle. Parallel lines have the same slope and they never meet. So another property that I want to show you of angles here is when we have two parallel lines that are cut by what is called a transversal. This line that's not parallel, that's intersecting both lines, is called a transversal. opposites on the transversal are equal. So you can see the 61 degrees is equal to 61 degrees down here. 119 degrees is equal to the 119 degrees right here. And we can see again that the opposite angles are equal, just like we just figured out. So problem 3. Let's find the measures of angle A and B given the properties of angles that we just learned. Well, let's think about this. We know that this is 180 degrees. A straight line is 180 degrees. So what is this angle going to be? That angle is going to be 180 minus 119, which equals 61, I believe, but I don't trust myself. Yes, 61. And we just learned that opposites on the transversal are equal, so that means that this is also 61 degrees. Opposite angles are equal, so that means angle A is 61 degrees. Let's look at angle B. So the opposite of 100 is going to be 100 degrees. Opposites of a transversal means this is going to be 100 degrees. It's on a straight line with B, so B is going to be 180 degrees minus 100 degrees, which is 80 degrees. So B is equal to 80 degrees. Another way that we can list angles is using degrees, minutes, and seconds. So instead of using decimals when we have angles that are less than 1 degree or are 1 degree plus something less than 1 degree, we can use minutes and seconds instead of those decimal degrees. So we have steps here on how to convert from degrees, minutes, and seconds to decimal degrees, and to convert from decimal degrees to degrees, minutes, and seconds. So the nice thing about degrees, minutes, and seconds is they work just like time does. There are 60 seconds in a minute. There are 60 minutes in a degree. So you can kind of think of a degree as like an hour. So let's look at converting from decimal to degrees. And you may sometimes see degrees, minutes, and seconds as DMS. So converting from to decimal degrees. So we know that it's still going to be 67 degrees. This whole number is not going to change. So we have 67 degrees. And we have to figure out what the decimal is going to be now. So what we're going to do is we're going to take 48 and divide it by 60. And there's our decimal for minutes, is 0.8. So that's going to be our first decimal place. Then we're going to look at our seconds. We're going to take seconds, divide it by 60 twice, and we get 0.015. So that is our final answer. So you'll just take the minutes, divide it by 60, and seconds you'll divide by 60 times 60. Dividing by 60 twice, or you can say you're dividing by 3,600. Again, the steps on doing this are right up here. So if you ever forget, you can refer back. Now we're going to convert into degrees, minutes, and seconds. So we already have our whole number, 26. That's going to stay the same no matter what. Now we just have to figure out how to convert this decimal place into minutes and seconds. So what we're going to do is multiply just what's to the right of the decimal place by 60. So 0.785 times 60 is 47.1. So we have 47 minutes. Minutes are just a single quote or a tick. Now we have the full minutes, we only have to worry about the decimal place again. So we want 0.1 times 60 again, and we get 6 seconds. And that is how you convert. So you can go ahead, work on problem 5 on your own, and next up we will be talking about triangles.